Hello everyone, welcome to this demo that will be about recommendations based on Python packages that are already shipped in pre-built container images. So let's get started. The overall goal is basically to adjust the resolution process in a way that it can take into account Python packages that are already installed and present in pre-built container images or runtime environments. This somehow supports predictive stacks idea, and we will discuss this feature further. At the end, I will show declarative interface for resolver that supports this idea, and I will demo how you can benefit from this feature in your resolutions. Okay, so let's have a look at adjusting resolution process based on Python packages that are already present in pre-built container images or runtime environments. Thoth engineers build container images that have some or can be used in some specific use case. An example can be a predictive stack for computer vision. So it's a container image that has Python packages specific for computer vision applications, and people can use these container images and use them in computer vision applications. These pre-built container images have packages that are known to work together. They are tested and crafted. It's a stack that is considered as a working application stack, ready ready to be used in users' applications. As these are container images, they can be used for additional installation of packages. So if you run a container image, pre-built container image, you can additionally install Python packages into them. The downside of that is that it will no longer be a predictive stack, so things might break. And this is the use case when Thoth can be helpful. Let's talk about an example. It's a very artificial example, but you can get the idea, you can get the notion behind it. So imagine we have a container image that is shipping TensorFlow in some specific version. So it's a predictive stack of TensorFlow in version 2.5.0, and it's shipped with TensorFlow and all the libraries that are used by TensorFlow and are needed to run TensorFlow. Then you use this container image, but you would like to install TensorBoard for checking how TensorFlow behaves in your experiments. Now you might ask which version of TensorBoard should you install into that predictive stack container image. And you can simply use pip install TensorBoard and let pip decide which version of TensorBoard should be brought into your environment. Or you can use Thoth, which knows which Python packages are already present in the container image and are shipped in the predictive stack container image, and can further adjust resolution based on knowledge, based on observations, so that it can inject the most appropriate TensorBoard version into the container image. So the workflow is quite simple. We have predictive stack TensorFlow container image. We want to install TensorBoard, so we ask Thoth which TensorBoard is the most appropriate to be installed into the given container image, into the given runtime environment. And Thoth, based on knowledge about Python packages, but based on knowledge also about container image, predictive stack TensorFlow, can suggest the most appropriate TensorBoard version together with transitive dependencies that are known to work in that predictive stack runtime environment. This can be done using declarative interface. Users can adjust the resolution process using prescriptions. That is a feature that we provide. So it's basically a YAML file where you state how the resolution process should look like. And in this YAML file, you can state how the resolution process should look like considering Python packages in runtime environments that users use. It's, as stated, it's a declarative interface. We can check documentation. So here I'm browsing documentation of Thoth's advisor. Specifically, I'm browsing documentation of declarative prescriptions for resolver. And if you search for Python packages, you can see a section that is inside runtime environments and should include. And this section can be used to declare which Python packages should be present in the container image in order to adjust the resolution process in some way. So what you can state, you can state a list of Python packages that should be present in the container image to adjust the resolution process. So each entry of these Python packages has three things. The first one is name, that is mandatory, and states name of the Python package that should be present in the container image to adjust the resolution process. Then you can state also version in a form of version specifier known in Python ecosystem. So you can do above specific version, below specific version, compatible with some specific version, and so on and so on. So version specifier for the given package version. And then you can provide also location. As Python packages can be distributed in container images basically anywhere on the file system, you can specify a location in which the Python package should be present. This location is in a form of regular expression, so you can do regular expressions in these locations, location specification. And an example can be matching Jupyter or micropipenv, a package that is installed in system's side packages, then the location is different. Then micropipenv installed in virtual environment that is created in Thoth's S2I or vanilla S2I. And in that case, micropipenv will be placed into a specific location on the file system, which can be specified in this prescription specification. Okay, so that's documentation, so feel free to browse that documentation. Let's take a look at an example. So here we have one pipeline unit that can be registered in the resolution process and can adjust the resolution process based on some criteria. So the pipeline unit is called test boot, and it's of type boot. So it's a specific pipeline unit type. Follow documentation of advisor if you want to get more information about it. We have one section that is should include section that states when the given pipeline unit should be included in the resolution process. So we include this pipeline unit when users use operating system Red Hat Enterprise Linux or UBI in version 8. And we include this pipeline unit that will adjust somehow the resolution process or inspect the resolution process when specific Python packages are present in runtime environments. So in this case, we are registering this pipeline unit if there is package, if there is not, but we can comment out this not at the beginning. So we will include this pipeline unit if micropipenv will be installed in the runtime environment in some specific version, in some specific location. So this is the location that is used by S2I tooling. If these criteria should include section are met, then the pipeline unit is registered in the resolution process and acts accordingly or adjusts the resolution process accordingly. In this case, it will halt the resolution process with this message printed to the user. Right now, I will run Thoth's advisor locally, but normally this is run in cluster, and reports that we will see in JSON format will be reported to users in a more user-friendly way. So here I'm running the resolution. And here you can see that the resolution was halted or was stopped as boot pipeline unit test boot failed. Means it printed the given message and halted the resolution. Let's take a look at environment that was supplied to along with the request. So here we are using operating system RHEL in version 8, running Python 3.6, and we use this base image for running our application. As this base image is analyzed by Thoth, Thoth knows which Python packages, what RPM packages are present in this container image, and includes the pipeline unit that we saw earlier. Okay, and now let's adjust our prescription in a way that we will not include the given pipeline unit if micropipenf is present in the specific location. So here we again run the same resolution process, but this time the pipeline unit will not be included as micropipenf is present in the container image. And here you can see that there is resolved stack that was very simple, and the resolution was successful. This is the declarative interface of the resolver. Resolver has also one capability which automatically adjusts resolution based on Python packages that are already present in container image. So if you recall the use case or the example with predictive stack TensorFlow, if users asks to install TensorFlow into this container image, then the resolver will report back that TensorFlow is already present in the container image that users use. This might look like a not good feature, but imagine that TensorFlow in this case is some dependency of package that users ask to install. So let's say user asks to install Horovod, and as resolver knows that TensorFlow is already present in the container image, and it knows that TensorFlow is dependency of Horovod, the resolver will try to use TensorFlow that is already present in the container image and will not reinstall the Python package in the container environment that users use. So that's a side note and feature that is also available. If you are more interested in this feature, you can follow justification that is printed to users in this case. If you are interested in prescriptions or the declarative interface for resolver that I talked about, you can follow documentation, and you can also follow a link to implementation if you are interested in details. This way, I would like to thank you and see you next time.